Hey guys, HackerSploit here, back again with another video. Welcome back to the Web App Pentesting series. In this video, we're going to be taking a look at HTTP cookies and sessions. So this is arguably one of the most important videos in this series, primarily because cookies and sessions are elements of web applications and web app pen testing that are quite important as you move along, and you'll actually see how this ties into vulnerabilities like cross-site scripting, for example. We're going to be taking a look at that shortly. But before we get started with the practical side of things, let's get an understanding as to how HTTP handles sessions. All right, now, if you remember in the introduction video or where I covered HTTP, I mentioned that HTTP is a stateless protocol, right? So what is a stateless protocol? Well, a stateless protocol operates under the same or the familiar client-server model, where the client sends a request to the server and the server responds to these requests, right? So you essentially ask for something and you get whatever you asked for. Now, stateless protocols do not retain or store client sessions, and as a result, the client is responsible for storing session information for future requests. What does this mean? It means when you make a request to a website via HTTP, that is not stateless. So the problem here, as you can already tell, is what if the server needs some sort of validation or is wants to implement some form of session management. How does it do this, given the fact that HTTP is stateless? Well, this is where cookies come into play, right? So I'll get into cookies in a couple of seconds, but the crux of this is that the client is responsible for storing information for future requests. Right, so this ultimately means that the client must include their session information in requests made to the server for authentication and or validation. So this is where cookies come into play. So cookies are used to store session information and other data sent from the server to the client side. So I'll just use a simple example. Let's say I'm making a request to hackersploit.org, right? Well, when I make the GET request, the server says, okay, thank you for making the request. What you're looking for is available. But what I want you to do is I want you to set this particular cookie, right? I want you to, essentially set or save this cookie. This cookie, I want you to save it in your browser, and it'll essentially contain your session ID and a few other important things that I require from you when you re-authenticate again. An example of this could be, your preferences for the website. So let's say you close a particular pop-up, then that information is handled within your cookies that are stored within your browser, so that the next time you make another request to that website or to that web application, your preferences are stored in addition to your session information, right? Now, the way sessions are handled is something that we'll be exploring a little bit in this video and in a future video when we get to that point. So cookies are typically stored, as you know, within your browser, right, within a temporary directory. That's because on your browser, whether it's Firefox, Google Chrome, Safari, etc., you have the ability to clear your history, and under clear your history, you can clear cached content or you can clear cookies. Now, what happens when you clear your cookies from your browser? It means that firstly, you'll need to log into all of the sites you're using previously. So if you've ever realized that, like, for example, if I'm signed into Google, then the cookie that Google gives me essentially has a very interesting expiry attribute. That means that, I can continuously open up my browser and I'm still signed into Google, right? Now, when I delete my cookies, that means that, all of that information regarding my session is lost. And as a result, Google will say, okay, you need to log in again so that I can send you a new cookie. So cookies are typically used to uniquely identify clients that are interacting with the server. And as I said, they're stored within a temporary directory on the client browser. Cookies are typically used for state management, as they can contain session IDs and other cookie attributes that we'll get into shortly. So when communicating with the web server, the web server will send a cookie to the client, or will send a response to the client with the set cookie header, essentially telling them what they need to save, or providing them with a cookie that they need to save, or the browser needs to save. So what are these cookie attributes? So what information is, pretty much the most important when it comes down to a cookie? Well, firstly, you may have a session ID. Session IDs are essentially a random string that are typically used for session management. So an example of this is on the, if you actually try and access a web application built on PHP, you'll typically have something like a PHP session ID, right? So that is used to uniquely identify you as a client or your browser for future interaction or requests that you may make. You then have the expiry attribute. Now this is used to specify an expiration date for the cookie. So this is, the server will send this cookie, but the expiration date essentially states when this cookie should expire. So for example, if I have a website and I, on the server side, I say that, okay, for all the clients, I want their cookies to expire after a week. Right. So let's say on the client side now, one of my customers logs into my website and, they get the cookie, it's stored within their browser. And, throughout that week, they can continuously open up their browser and, they can access the site without having to log in. However, after the expiration date or when the expiration has lapsed or, the validity period for that cookie has lapsed, then I'll need to log in again to get, another cookie. You then have the domain attribute. This specifies the domain or domains where this cookie can be used or where it's valid. You then have the path. This is used to specify the resource or path where this cookie is valid. So, the URL, it could be to a particular directory, maybe a specific dashboard or for a specific file. You then have the HTTP only attribute. This is really, really important. This is one of the areas I'll be focusing on in this video. So if this attribute is enabled, this will prevent the cookie from being accessed via JavaScript on the client side. You'll actually see this and why this is so important and why this is typically enabled on production sites. You then have the secure attribute where if enabled, the cookie will only be sent over HTTPS. Again, that's quite useful, very, very important, because if a cookie contains, if it contains a session ID, then if it's sent over HTTP, which is not encrypted, then a man-in-the-middle attack can essentially sniff out those requests and identify your session ID or pretty much your entire request with the cookie, information itself. Consequently, you get the idea. Attackers can then pretty much, perform impersonation, etc. So I mentioned session IDs quite a lot. So what is a session ID? Well, session IDs are unique identifiers that are used to identify users and their respective sessions. So where are session IDs stored? Session IDs are typically stored in two primary areas. I've not mentioned the other ones, but these are the ones you'll typically see. So the most common one is they'll be stored in cookies or, as a URL parameter. So if you've ever seen within your browser, or let's start off with cookies. So if you've ever intercepted a request with Burp Suite, you might have noticed that the session ID is stored within the actual cookie, right? Or the cookie content. And then in the case of URL, again, the same concept applies. If you've ever logged into a site, most likely a PHP site, in the URL, you might have noticed that you have a PHP session ID parameter, and the value has the PHP session or the actual ID itself. So there's multiple ways that they can be stored. Now, one thing that I wanted to point out is, given the use case of session IDs should abide by the following guidelines. So, from the perspective of security, session IDs should be random and unique. They need to be sent securely. So over, preferably an encrypted tunnel, so HTTPS, TLS, etc. And they should be lengthy and should never be reused. Given the fact that we know session IDs are used to uniquely identify users, then of course they need to be random and unique. So other users should not be able to guess them or should not be able to essentially identify or get that session ID under any circumstance. They need to be secure from man-in-the-middle attacks. So that means they need to be sent securely. They should be lengthy. That ties into the whole concept of them being random and unique, and should never be reused. So two users should never have the same session ID. You can pretty much guess the problems that would cause. Okay, so now that we have an introduction to cookies and sessions or session IDs, let's take a look at, a practical example. So we're going to be utilizing the damn vulnerable web application. So I'm running it within the Docker container. If you check my previous videos, you can actually learn how to set it up yourself with Docker. It's really cool. And I'll walk you through a few interesting aspects of cookies and session IDs and show you what I mean from a security perspective, and from the perspective of an attacker, you'll be able to get a better understanding of how cookies can be exploited and where they apply. All right, so let me just switch over to my Kali Linux virtual machine. All right, so I'm back on my Kali Linux system, and I'm just going to start up the Docker container. So this is the vulnerables, damn vulnerable web application, and I'm just exposing it on port 80 locally. So I'll start it up, and we'll give this a couple of seconds. And I've already started Burp Suite, but Intercept is disabled for now because I want to explain a few things. Right, so that should be working. So let me open up my browser. I should be logged out, and we'll just close that. All right, so it's working now. We need to create the database. So setup.php, and I'll just say create the database here, and I can then log in. So the default credentials for the damn vulnerable web application are admin and password. All right, so let me log in. There we are. Fantastic. So, very simple web application. We should already have a cookie, but let's take a look at it from the beginning. So what I'll do now is I'll log out. You might be a little bit confused, but don't worry. I'll just enable the Burp Suite profile with Foxy Proxy here, and I'll enable intercept on Burp. And let me just refresh the page. So you can see when we make the GET request, the server will respond with the cookie that we should use. Now the cookie in this case contains the PHP session ID. So what's happening here is we've requested for the page itself, or, we've essentially trying to access the site, and the server has responded and it says, okay, you can access the site, but I want you to save the following cookie. So PHP session ID, and then it gives you the unique, session ID. And then we have another one, which is security. So this is another additional piece of information that is being passed being passed along by the web server. In this case, because this is the damn vulnerable web application, this is used to specify the security level. So from this point, we can pretty much customize or modify it, but that's really not going to affect the application itself. We're just going to be able to increase the security level, etc. So again, just to make sure that you understand, this is not reflective or related to how applications would typically utilize cookies. This is just in the case of the damn vulnerable web application. So I'll just say forward. Okay, and if we click on Cookie Manager is a really cool Firefox extension or plugin, whatever you want to call it. It allows you to manage and edit your cookies for different sites. So I'll just open up, I'll say search cookies for localhost because I'm hosting this locally. And you can see that this is the cookie that is stored for the following website. So the cookie has, the following attributes, and then it has the additional information. In this case, this is the second one, so security low. But for PHP, you can see these are the two cookies here. So PHP session ID, that's the cookie. You can see all the attributes here, which I'll get to in a second. However, if we now try and log in now with credentials, I'll just say admin password. Right, I'll just say login. You can see that the web server now says, okay, you want to log in. For your login, I want you to use the following session ID. Now you might be a little bit confused. If I told you that session IDs are used to track, are used for session management, you might be saying, well, we didn't log in yet. Why did we get a session ID previously when we were anonymously browsing the site? Well, that's because session IDs can be used in both ways. It can be used for anonymous users, where it's really non-consequential, but still very useful in tracking your session. And then, of course, they can also be used for authenticated session management. So just take note of this cookie here, right? So TNJ3PA. So I'll just say forward. And you can see the same one there. So forward, and then we click on the cookie manager here. You can see that it's the same cookie. Oh, sorry, it's the same session ID here. All right, so we're now logged in. Okay, so we're logged into the damn vulnerable web application. Nothing special there. What I wanted to highlight was a few things. So I'm now going to be utilizing the cookie manager, because you can really do a lot of cool stuff here. So the cookie manager, you should be able to see all your other sites that have cookies here, but in my case, I cleared all of them because I wanted to explain this. So this is our cookie here. All right, so you can see these are all the attributes. We have the domain, localhost. The name of the cookie is PHP session ID. That value is specified in here. You have the ability to decode it with to perform URL decoding, which I'll get to in another video, and then base64 decoding. In this case, the session ID is random and it's not encoded insofar as I know. You then have the path, the context, etc. Right? But what we are interested in here are these three. These three. So you can see at the bottom that this attribute is session, and I didn't cover it in the slides for a very important reason, is enabled or it's checked. So what does that mean? As you can see, if you highlight or you hover over this, it'll tell you that if enabled, this will check or will force the cookie to expire at the end of the session. Now, the great thing with Cookie Manager is we can modify all of these attributes and consequently change the way we interact with the web application. What do I mean? Well, if I disable is session, I can specify another expiry date. But before I do that, I want to show you that this does indeed work. So to show you that this works, I'm just going to close my browser, right? So because it's currently checked, that means when I exit from my browser, I'll need to log in again to the damn vulnerable web application. So I'll just say close tabs, and I'll open up Firefox again, right? And we'll give that a couple of seconds. So I'll say localhost. You can see I need to log in again. So I'll just log in one more time. There we go. And now let's modify this cookie. We should have a different PHP session ID, right? So search cookies, you can see it's now different because our session is different. So if we wanted to persist the same cookie, then we can disable is session and set a different expiry date. So I can say I want this to expire on maybe Friday of, the 22nd of April on Friday. I can then save that. I probably need to save that again. So 22nd, there we are. Save it. All right. So now that we've saved it, we have essentially modified the cookie attribute to say, or to essentially state to the server that, hey, I have the following cookie. It doesn't expire till the following date. So please give me access. All right. So let's test this out. So remember, I'll just close up my browser. This is what you'll typically see, as I said, with a site like Google or Facebook that maintains your session, or the validity of the actual cookie itself have a specific date. After a while, you may be forced to log in again, but that's based on the actual company that set up that website. So I'll start it up again. And we'll just open up localhost again. Remember, I shut down my browser completely. There we are. So we're now logged in. We don't need to log in again. So again, the reason I'm showing you this is to show you that cookies are really, they play a crucial role when it comes down to session management and the way the client interacts with the server and vice versa. Okay, so let's take a look at the cookies again. So I'll just search cookies for localhost. You can see it's the same one. Now let's take a look at some of the other attributes. Some of the other attributes, the one that I wanted to cover is the HTTP only attribute. So this is a theft protection. So this will check to force the cookie to be sent only over HTTP or HTTPS. Make sure to note that. So what this does is it essentially blocks JavaScript access like in a cross-site scripting context. What on earth does this mean? Well, you can see it's currently unchecked, which means that on the client side, I can pretty much utilize JavaScript to interact with the cookie or to get the actual cookie. So if I inspect element here and I head over into the console, I can use JavaScript to say document.cookie and it should display it. So there we are. It actually displays the cookie there. So PHP session ID security equals low. All right. And an attacker, and I'll walk you through this with cross-site scripting, but we can essentially say alert alert, and within this we can say document. I don't know if you can actually see this. Let me just zoom in. So document.cookie. If I hit enter, you can see that this is typically what, we would now be getting into the territory of cross-site scripting, and I'll actually show you a practical example where this could potentially be dangerous and why that always needs to be checked on a secure site. So you get the idea. When that attribute is not checked or enabled, then we can pretty much through the client side interact with the cookie via JavaScript. So let me go back in here. And what I'll do now is let me just check that. So I'm going to save it. There we are. So that's saved. And now let me just, we can refresh the page. That shouldn't affect too much of the functionality. But if I now say document.cookie, you can see we now get an empty string, or, we essentially get an empty value there. So you can actually see how this is helpful. And if we repeat our previous example where we try and generate an alert box, you can see it doesn't display it. So you might be asking yourself, well, that's really interesting, Alexis, but how does this tie into web app pen testing? Well, I'll show you in a couple of seconds, because as said, these set of introductory videos are explaining a lot of the foundational stuff that a lot of people ignore. But if you understand it, things like cross-site scripting become much easier to understand, things like cross-site request forgery, etc. So what I'll do now is let's go ahead and uncheck it or disable it, right? And there we are. Fantastic. So I'll just go back in here and let's go into cross-site scripting stored. All right. So you understand pretty much how this works. This vulnerability essentially allows a potential user to essentially in this context inject JavaScript code into the actual web page, so that when other users access that page, that JavaScript is executed on the client side. Now you might be saying, well, how is that useful from the perspective of an attacker? Well, if you customize the JavaScript, you can actually have it send the information of the other user who is accessing that page to you. For example, you can steal the actual cookie itself, the PHP session, all of that good stuff. So let me show you how this works through a very simple example. So I can call this one, we can just say cross-site scripting, and within here I can say script, and I can say alert. Let me put this in brackets here. So document.cookie. All right. And we just close that script tag there. And then I'll say signed guest book. All right. So you can see that when that attribute is disabled, when the HTTP only attribute is disabled, because I've been able to inject that cross-site, that JavaScript code onto this page, the JavaScript is executed. And in this case, for the purpose of this example, the cookie of a particular user, in this case myself, is displayed to me. But if you're aware of cross-site scripting, there's multiple ways you can sort of get that information. So let's try it again. All right. So if I refresh it just to show you, it's displayed again because it's being okay. So it's working. So I think we actually resubmitted that, but this will work perfectly fine. So I'll just enable HTTP only now. So HTTP only, there we are. If I refresh that, send, you can now see, because we've enabled that attribute, we cannot interact with the cookie via client-side JavaScript. So that information is essentially kept secure. You're starting to understand how important this is now. All right, so that was one of the examples. Now, what I also wanted to cover again, and this is, I'm not really sure whether I wanted to cover it, but if we take a look at the is secure one, this will only force, this will check to force the cookie to be sent only over secure channels, but that's really not important. But we can actually check it out to see how it works. So, that works out just fine. And then, of course, we have the same site policy, or the origin policy, but that's something we'll be exploring in another video. Now, what you can also do is you can also analyze the security of a cookie. Let me just remember, I'm editing this on the client side. If I request or if I log out, the web server will send me another cookie with the default attribute values set or enabled or disabled. So again, I'm just doing this on my end. So that means that the actual server really, or the actual web developer himself, is really in control of cookie security, if you will. So the other way we can do this is we can actually test the security of cookies with Burp Suite. So let me just switch over there. So I'm just going to say home. So what I'll do here now is let's head over into weak session IDs, and what I want to do is let me just enable the intercept. So this page will set a new cookie called the damn vulnerable web app session each time the button is clicked. So just take note of that. I'll explain what this means. So we can click on generate, and you can see now, in this case, did it actually do it? Let's say forward once again. We say generate again. There we are. So the damn vulnerable web app session ID. So this is testing session IDs. So disregard PHP session ID for now. That's done by PHP itself. So just keep that in mind. What we're testing here is the security of a session ID. Now this is weak. Why is it weak? If you remember the slides, this is not random. It looks sequenced because it's starting from 1. Let's test it a little bit more. I'll say forward. Let's click on generate again. So the next session ID is 2. All right. So from the perspective of an attacker, if they know that this is not random and it's sequentially handled, then they can just type in whatever number they want, and they'll be able to sort of impersonate that session, or, at a very basic level, do some level of impersonation. So the way we can test this is by sending this to the sequencer. So I'll send that to the sequencer here. And we can, specify the cookie. So dvwa session 3. And, let's see, do we need to modify anything here? We can just start the live capture. So it's going to go through, there we are. It's going to begin the live capture. So it's going through all the actual requests and tokens. So we'll give this a couple of seconds to complete, and I'll explain why we're using this. So again, remember, this is being done for the low security level, which is expected. That's what DVWA was developed to do, is to show you how security differs from poorly secured sites to, I would say, quite well secured sites. So we can click on Analyze Now, and you can see right over here the overall result. The overall quality of randomness within the sample is estimated to be extremely poor. At a significance level of 1%, the amount of effective entropy is estimated to be 0 bits. So effective entropy, the chart shows the number of bits of effective entropy at each significance level based on all tests. Each significance level defines a minimum probability of the observed results occurring if the sample is randomly generated. When the probability of the observed results occurring falls below this level, the hypothesis that the sample is randomly generated is rejected. Using a lower significance level means that stronger evidence is required to reject the hypothesis that the sample is random, and so increases the chance that non-random data will be treated as random. So this essentially tells you, if you scroll down right over here, it'll actually give you more information regarding this particular live capture and analysis, but it's essentially telling us that this is extremely poor, because it seems to be there doesn't seem to be any randomness involved. So what I'll do now is we'll go back to the proxy. Let's forward that there. Let me just disable intercept for a second. We'll set this to high. So DVWA security, we'll actually set it to medium, and we'll test that out as well. Weak session IDs, let me make sure intercept is on. Generate. Okay, so we now have something a little bit more complex. Doesn't really look random. It could be, but it's quite short. That could be a potential issue, right? So let's send this to the sequencer again. All right, sequencer. Let me just get rid of that there, and I'll send it again. Should have done that previously, but there we go. And we'll start the live capture. So again, just going to wait for this to complete. All right, so let's analyze the medium security level. So in this case, it looks like it's the same here. I'm not really sure whether that is Yeah, that's the correct request there, but it's still telling us that the security here, the randomness is extremely poor. So if we take a look at the actual, no, I think this is still character position, bit position. Yeah, I think that's the correct one. But if we go back here, right. Oh yeah, that's the correct one. So again, it's still poor. So let's just repeat the process once more. So remove, and we'll go to proxy for that. Let me just disable intercept here. DVWA security, let's set it to high. Maybe we'll get a better level here. Weak session IDs, intercept on, generate. Okay, that looks much better now. So we can send this to the sequencer. There we go. Let's make sure that that is correct. It looks like it is. That's the cookie there. It's not from a form field or a custom location. So that's the actual token. So let's start that here. It should only take a couple of seconds. Hopefully I don't have to actually have to wait for this to complete, but this, you can actually see it seems to be a high level of entropy in this case because it's taking much longer, but we'll actually see what the summary is. So just gonna wait for this to complete, and we should be able to wrap up this video then and move on to the next video where we'll be covering how to use Burp Suite, because if you're not familiar with Burp Suite, then you're half as effective. So analyze now. All right, taking a bit. There we are. Fantastic. So the overall quality of randomness within the sample is estimated to be excellent. At a significance level of 1%, the amount of effective entropy is estimated to be 118 bits. You can take a look at the significance level there and the reliability, right? So it'll tell you what sample size it used and the token length. So again, the most important thing is the actual length of the actual token itself, or the session ID, if you will, and the actual randomness of it. So that's how you can analyze a session ID security, if you will. And of course, this ties into bug bounty. So maybe that's a little tip or trick for you guys there. So let's forward this here. We've set it to high now. I wonder whether the cookies have changed. I wonder. Let's see. We'll probably need to re-authenticate, but yeah, it's the same one here. The only difference, as you can see, the session attribute is essentially checked or enabled. If we take a look at, let's see, I think we've gone through all the examples that I wanted to highlight. We pretty much only wanted to take a look at session IDs, cookies, and of course how that ties into cross-site scripting, which we have. Let me just turn off intercept here. And of course, you can continue testing with higher security levels. But yeah, I think that's pretty much all that I wanted to cover in this video. Let me know if you have any questions or suggestions. You can leave them in the comment section. If you want to contact me directly, you can do so via Twitter or the actual HackerSploit forum. The link will be in the description. And if you want to support the channel, you can do that via Patreon. The link to that is also in the description section. With that being said, thank you very much for watching, and I'll be seeing you in the next video. I just want to take a couple of moments to thank our Patreons. Thank you, Michael Hubbard, Dustin Umpress, Jerry Speds, Doozy, Sid Saab, Ryan Carr, Shamir Douglas, Jojo Bibi, Palangos, Kushkev, RS, Nino Buikov, and David Bricker. You guys are really awesome. Thank you very much for supporting us, and you guys make these types of videos possible. So we really appreciate it, and we look forward to producing even more high quality content.